Alright, so this question says that the equation of a curve is y equals x cubed plus px squared, where p is a positive constant. Show that the origin is a stationary point on the curve. Yes, origin is 0, 0. We have to show that at 0, 0, dy by dx must be equals to 0. And find the coordinates of the other stationary point in terms of p. Okay, so find the coordinates of the other stationary point. Okay, first we have to show that dy by dx is going to be equals to 0 at the origin. So if we find the expression for dy by dx, it's going to be 3x squared plus 2px, and show that when x is equals to 0, dy by dx is also equals to 0. Let's show that. So 3 times 0 square plus 2p times 0 gives 0. So when x is equals to 0, dy by dx equals to 0, and also show that when x is equals to 0, y is also 0, because they said that on the origin dy by dx should be 0. So when x is 0, y is going to be 0 cubed plus p 0 squared. So hence at origin dy by dx is equals to 0. So 0, 0 must be a stationary point. Okay, now we need to find the other stationary point of this equation. So for that, we equate dy by dx to 0. So equate this to 0. Yeah. Show that the origin is a stationary point of the curve and find the coordinates of the other stationary point in terms of. Okay, so we have equated it, and we have equated it to 0. Now we have to find x in terms of p and also y in terms of p. Let's factorize the left hand side. X common, we get 3x plus 2p is equals to 0. We get x is equals to 0, and we get x is equals to minus 2p upon 3. When x is 0, y is 0, we've also seen that. We've already shown that stationary point. Here, find the value of y by substituting minus 2p upon 3 in place of x in the original equation. Okay, that gives us minus 8p cubed upon 27, and that's going to be plus p cubed. There's going to be a 4 here and a 9 here. Let's add these. I'm going to ignore p cube in the calculator. So minus 8 upon 27 plus 4 by 9. Oops. Okay. Plus 4 by 9 gives 4 upon 27 p cubed. So y is coming out to be 4 over 27 p cubed. So the coordinates of the turning point are 0, 0, which were already proven. No need to write that again. And the other one is minus 2 over 3p, comma 4 over 27 p cubed. This is the answer for part 1. All right, moving on to part 2. Find the nature of each of the stationary points. Okay, so for the nature of stationary points, we have to tell if this is maximum or minimum, or if this is maximum or minimum. So we already have the first derivative. Let's derive it again. D square y upon dx squared would be 6x plus 2p. Now we have two values of x. When x is 0, the second derivative comes to be 2p, and we already know that p is a positive constant. So that means this is bigger than 0. So 0 comma 0 is a minimum. Okay. Next is x is equals to minus 2 over 3p. Let's substitute that. We get 6 times minus 2 by 3p plus 2p, which gives minus 4p plus 2p, which is minus 2p, which is less than 0, which implies that this other point minus 2 by 3p comma 4 over 27p cube is going to be a maximum point. Okay. Last part of the question is another curve has equation y equals x cube plus px square plus px. Find the set of values of p for which this curve has no stationary points. Okay, what is it meant by no stationary points? That means that the derivative is not going to be equals to 0. So this means dy by dx should not be equals to 0. Let's find dy by dx, 3x squared plus 2px plus p. This should not be equals to 0. That means that this curve, wherever that is, it can never touch the x-axis because it's never equals to 0. So this is the case where the discriminant is less than 0. You do not get a solution of a quadratic equation. So b is 2p, a is 3, c is p. So we get 4p squared minus 12p less than 0. First I'm finding the critical values. 2p squared minus 12p is equals to 0. Ignore the inequality. We have 4p here. P minus 3 is equals to 0. So we get p is equals to 0 and p equals to 3. But the question was in terms of an inequality, and when it's less than 0, we write the final answer as a full domain, starts from 0, ends at 3.